For this project, we will be designing an ornithopter that flies by using flapping wings. The materials we'll be using consist of balsa wood, paper clips, a rubber band, and tissue paper.
As you can see in our video, we have created our first draft of the ornithopter. The ornithopter does not like to flap its wings on its own and requires manual help. It does not fly on its own, but it holds itself together even when the rubber band is unwinded by hand.
Some things that we will change with our design will be using different paper clips. So an issue we had with our paper clips is that they have a coating that makes them hard to turn and bend into different shapes. Another thing is a better rubber band, just to see what that does differently and if that actually affects how things rub together. And then also tubing of smaller diameter, because we were just using straws and everything that was supposed to go into the straws was very loose. So it had lots of room for error and it could move freely when it should not be able to.
In the end, our goal is to try to have a cleaner, more slick-looking ornithopter similar to the picture above. A lot of our next steps involve fixing up a lot of our previous designs, which will hopefully let everything fly much smoother than previously thought.
For our new design, we decided to change the wings. So now we're using square wings instead of the semicircular wings that we previously used. This was to see if we could generate extra lift. We also used a different material so that more air would be trapped underneath the wings and not be able to get through the porous tissue paper. We also changed the tail so that it has a greater surface area to see if that would affect stability. We also added weight to the back of the motor stick so that in order to move the center of gravity back. And then we were also having an issue where it was dipping left when we were flying it, so we added extra weight to the tip of the right wing. Finally, we also used different support materials in order to not have it break every time that it crashes.
Here are a few of our final test videos that we performed in order to test our different variables. After changing all of these different aspects, we weren't able to get any successful flights. However, throughout the different iterations, we were able to slow the fall down of the ornithopter. We believe this is due to the fact that we increase the surface area of the tail as well as the surface area of the wings and the different materials. In the future, we will try to decrease the mass of the ornithopter while still increasing the frequency of flaps in order to get it to actually fly.
Yes.